And we're back with Online with an Architect with another exciting episode. Really great topic today, and even better guest with us. Very happy to have Luis Chanu with us. Welcome, Luis.
Thank you very much for having me. Hello there, everyone.
So, yeah, Luis and I have been working on a lot of stuff in the background, actually, and this is part of it, and I think it's going to be a great topic. So, yeah, very lucky for everyone listening. So, Luis, for those of you who don't know, can you give us a quick intro of yourself?
Certainly. My name is Luis Chanu, VCDX 246. Been working with NSX since the early NSX V days. Focus now is NSXT, of course. Also have quite a bit of a background in Cisco route switch, have several of the CCNPs, and grew up with Microsoft. And for those of you that remember NetWare, that's where I first started. So that's kind of my background.
Fantastic. And look, there's not a lot of VCDXs in NV. So can you tell us a bit about your VCDX journey?
Certainly. Yeah, when I first came across NSX, it was in a beta class, and my love for route switch and then my love for virtualization, it was a natural fit. I thought, I kind of kicked myself for never finishing my CCIE. So after that, I figured, I like what I see. I got to dive in. So that started my journey throughout the whole VCDX process. It's an amazing process. You learn so much by just diving into it and really, getting to the meat of the product and how all the options work. And so that's kind of, that whole aspect of it. Also enjoy doing a lot of teaching. So I mentor folks in both route switch as well as the VCDX. That's kind of my background.
What do you think the best takeaway for you from the VCDX Ninja or NSX Ninja program was?
The Ninja was fantastic. I liked the depth that we got into everything. It was some really good discussions. You had people there that were core with the product. So as topics came up, you say, oh, hold on a second, I need to understand this better. You do a little sidebar, you drill into it. And even afterwards, you've got a lot of folks that also attended that you can have discussions with. It's just that community and being able to really get to the core answers to the questions that arise.
Yeah, fantastic. Now, I've heard a lot of good things about NSX Ninja, and a bit jealous I wasn't a part of that group, but that's all right. I'll continue my VCDX NV journey, which I said on an earlier episode. I'm committed to achieving that in 2024. So hold me accountable, please.
I will do that.
And I look forward to the mock panels from you just destroying me. So that's going to be a great learning experience. All right. So today's episode, this is one I asked Luis if he would be willing to do, and he begrudgingly agreed because he knows the level of detail that I like to go into, and we've had a lot of fun preparing. And I thought this was such a good topic. NSX deployment topologies. Obviously, NSX is a critical product. It's very important that it's deployed right the first time, and we don't want to make mistakes. So today, that's exactly what we're going to talk to. So let's jump in. So the first topic. So we've basically got our fictitious customer, Acme Corporation. They've chosen NSX as their strategic networking and security platform, which is, of course, a fantastic choice. A key focus for Acme is to have enhanced security by way of a zero-trust architecture at their existing data center, and they want to leverage NSX to achieve that. So we're going to talk about what the most suitable deployment topology is. The second topic we're going to talk about an extension of that, where the CEO wants to get a disaster recovery scenario. And then we're going to talk to a further expansion of that, where the customer has expanded into a third data center. So lots of really good topics and discussion here.
Definitely.
All right. So just recapping here, the customer is a small company. They only have a single data center. And due to that, they also have limited financial resources, as many customers do. In order to mitigate the potential security breaches, management is requiring that communication between all workloads be restricted to only those that are required by the workloads, which of course makes perfect sense. All other inter-workload communication should be blocked or denied. The customer has already purchased NSX Advanced to address these requirements. The solution should have a negligible impact on performance. Management also wants to provision infrastructure to be more agile, to accelerate the deployment of new apps in the future. And of course, the question begs, what is the correct or the best, most suitable deployment option? And of course, the answer is, it depends. So let's dive into this a
Always
little bit.
the answer.
Absolutely. So we've put together some requirements here. The existing single data center needs to be protected. Communication, of course, must be restricted to only the flows that are required. Everything else must be blocked or denied. Workload performance should be very good, and NSX should have a negligible impact on that performance. We obviously want to have our provisioning more agile in the future, and jumbo frames for the underlay network. So we're going to map back to these as we go through, so no need to write any of these down.
And just to clarify on one of those items there, what we're really talking about here is micro-segmentation, and so that's really what requirements 2 and 3 are all about. So for those of you on the listening to this, that's really the focus that the customer is after in this situation, is the micro-segmentation at their single location.
Certainly the most popular use case for NSX.
Definitely.
So our constraints. So no additional products or solutions can be leveraged due to limited financial resources, and customer hasn't got budget for new hardware, so the existing hardware must be utilized. So again, very common scenario. So I think this one is very important, actually, that anytime we design and deliver a project as architects, we should always encourage the customer to ensure they have some formal training before the handover occurs, because NSX is a great example of a product that is not simple. And if you try and hand over an NSX environment to someone who doesn't have the basic understanding, it's going to be very difficult to maintain and manage. So This is just, I guess, a pro tip from Luis and I. Make sure the staff managing an environment get proper training ahead of the or ideally before the project, but even during a project and certainly before handover, so that you're setting them up for success.
Yeah, so one thing, let me expand on that a little bit. What I often will do with the customer is I'm a co-developer of a product on GitHub or a GitHub project called SDDC Lab, and it'll deploy a fully nested SDDC environment. And so what I've often done with customers is we'll talk to them about the project, and then we'll set up a fully nested environment for them using the SDDC Lab. And it allows them to see what the environment will look like. They can try different things without worrying about blowing anything up or causing errors. And if they do end up causing an issue, we just wipe it and we redeploy it. It's all Ansible based. So that's really how I tend to start off the whole training and handover. I shouldn't say handover, but the whole training and just getting them comfortable with the environment. And then from there, we just extend on providing additional, over-the-shoulder training if needed, or really whatever the customer wants. But building up a sandbox is critical, especially if nobody's ever touched the product.
Yeah, I couldn't agree more. That's a great tip, and we'll make sure we put a link to that as well. So the second assumption is we're assuming the ESXi servers have sufficient resources for all the NSX services that are going to be used in this project. And we're assuming we can't purchase or acquire additional server hardware because that was one of our constraints.
Yep.
So risks. This is, I think, risk number one is very common as well. It's not just related to NSX, it's just in general. The customer may not know the required communication flows of their various applications and may require an assessment to discover and document the dependency mappings and other details. I think this is true for most people. I'm sure you see this a lot.
That's very common. And documentation from various products isn't always correct. So it's good to actually discover the flows using a tool rather than relying solely on documentation. Trust but verify.
Yeah, absolutely. I remember a lot of projects actually where you read the documentation, you set up the firewall rules, and then something doesn't work, and you're like, why isn't this working? And you do a capture, and then you realize, oh, actually, there's a few other flows that are not in the docs. So documentation's not always perfect. So always verify those flows.
The other thing I'll point out on that is, don't just assume that the flows that you see in a week or so are sufficient, because often customers will have end-of-month processes or end-of-quarter processes. So you'll want to run or obtain that or do that discovery for a longer duration of time to really make sure you're seeing all of the flows that the various workloads are needing or requiring.
Absolutely. And that's true for even like performance assessments for workloads as well. It's end of month. If you don't capture that, you haven't seen your storage or your CPU, your RAM usage during those peak times. So, yeah, great tip there. So the next risk is we don't have another data center. So there's no available DR site. So recovery from a DR event could be prolonged, and it might need the environment to be rebuilt, restored from backup, and so forth. So the customer needs to be very well aware of that. And further to that, the company's limited financial resources mean they're probably cutting some corners elsewhere. So this is also something that we need to be aware of. So, Lewis, maybe you can run us through our options here. This is where we get into the weeds.
Certainly. Yeah, so NSX, there are different deployment options depending on what your needs and requirements are. The first one is single location, and that essentially it's just what it describes. It's a single site where you have all of your NSX or ESXi hosts and your NSX infrastructure. Multi-site is an extension to that where you can, it's still quote unquote like a single site, but you have a data center interconnect or a DCI to another location that is very close to you, and you can extend your networking there, and that's really multi-site, so it expands up to that. And then finally, federation is when you have multiple locations, longer distances apart. Each one is like its own private island. Federation brings those together so you can have centralized policy, management, firewall rules, things like that. That's especially useful if you're planning on vMotioning workloads from one site to another, and you need to make sure, for example, that your firewall rules will follow the workloads across various sites in your enterprise. That's kind of where federation comes in. So those are the three different deployment options that NSX has.
And I guess the listeners can probably guess what we're going to talk to in these three examples. So a good little teaser here. All right, so our all-important decision for this first design decision is we've chosen to go with the NSX single location model, unsurprisingly, Lewis.
Best one for the requirements.
Absolutely. So let's talk to that. So absolutely, it's got to fit the requirements. So run us through these. Tell us why we've made this decision and why we didn't do something else.
Certainly. So given the customer only has a single physical location, that's all three of those, of course, will meet those needs, but single location just makes the most sense from that perspective for that reason. The overlay networking is something that would help with regarding future capability. So we're looking at implementing overlay segments or overlay NSX segments to get them ready for that. That'll also help with the future expansion down the road when they start wanting to bring in other sites. Because of their requirement of blocking unwanted traffic between workloads, that's where the NSX distributed firewall comes into play. And so we're going to implement that, and that gets implemented in kernel space. And that's really designed for east-west traffic to permit or deny that accordingly, depending on what your policies are. But the main thing there, if you notice, is the kernel space. By leveraging the distributed firewall, you can get near wire speed or at wire speed in terms of the firewall, and you don't have to worry about it impacting or increasing delays and things like that. Just to extend on that, to go to number 4, the DFW or the distributed firewall is the tool inside of NSX that enables you to limit or restrict communication between the workloads, even if they're on the same segment, even if they're on the same ESXi host or another ESXi host. And if you vMotion a workload from one ESXi host to another, the DFW state or the state of the firewall rules will move with it. So that's really where the power comes in terms of locking down an environment, is leveraging the distributed firewall rules with things like dynamic and static groups if you need to do static. In terms of, by static, I mean the members of the groups. You can apply tags to workloads and then have those workloads dynamically added to a group, and then use those groups as your source or target for the distributed firewall. So that's kind of a good justification or an overview of what this customer needed, and that's currently the plan.
Absolutely. I think there's not a lot of justification here because it sort of just does what they need. It's the perfect fit.
It's very basic in terms of what the requirements are with respect to that.
Yeah, indeed. So implications, of course, just as important as our decision and justifications. So what are we talking about here?
So this right here is kind of a future item, but so if you know you are going to grow into multiple data centers and you know you're going to need to go to federation, you could actually create a single site federation and get everything ready for that. So when you are single site or you are multi-site, your objects get created in what's called the local, and I know we haven't talked about this yet, we probably should. So let me back up for just a moment. When you have an NSX deployment, you have your NSX manager cluster. And the cluster's encompassed of 3 NSX manager nodes. And those 3 nodes form a quorum that then, of course, form your NSX manager cluster. And you have what's called a local manager. If you are in single site or in multi-site, the NSX manager cluster is quote unquote local. But when you go to federation, you then have another set of NSX managers called a global NSX manager. So in that scenario, you have global and local at each site and global across the entire enterprise. If you know you're going to go down the road and go to federation, there's nothing wrong with deploying federation from the beginning, assuming you have licenses and everything else, and already get all of your objects as global objects. Any objects created in the global manager are global objects. Objects created in the local manager are local objects. And as you can imagine, as you'll see as we get further into this, there are some limitations as to what objects can be used where. So if you start out with a single site and then later, let me rephrase that. If you start out with a single site, you develop all of your policies and groups and everything, and then down the road you go ahead and at that point you want to bring in federation. All your objects will need to be converted or from local to global with respect to the ones that you want to be enterprise-wide. If you have the foresight into the future and you know you're going down that path, you could decide to go ahead and do federation now, even though it's only a single site, and then it makes growing easier down the road. Of course, this does require specific licenses, which we don't have, and that's why it doesn't make sense for us in our scenario here because of the licensing constraints. And at this point, the customer isn't sure what they're going to do down the road. But I just wanted to point that out here, just give you some things to think about as you're thinking about your single site. Think down the road. If you know something that's coming, you can plan for it accordingly.
Absolutely. And yeah, if we did deploy that global manager cluster, there'd also be more resource requirements and things like that. So obviously doing that today for this customer isn't the best idea because they do have a lot of constraints, but hence we need to understand the implications.
Yeah, and there is a migration. So when you, as you onboard a site, you can do a migration, but there's some, I don't want to go too much into it here because it's a little bit more involved than what I'm just making it out to be. But there is a one-time migration for a site that is being onboarded, and I'll leave it at that. It is discussed in the documentation.
Fantastic. So our first decision, fairly simple one, fairly straightforward because it is a single site and we do have a lot of constraints. So some of the related decisions that we're going to talk to, obviously, in this episode is decision number 2 and 3, different deployment topologies over different data centers. And then, of course, coming soon, we're going to talk to some more in-depth topics as well. So
I think you meant 1 and 2 there, right?
Yes. All right. So let's jump into possibly a more interesting and more in-depth decision here. So we've got NSX deployment topology across 2 metro data centers for disaster recovery. So a year later, the customer has grown and recently acquired a second building. Management would like to take advantage of the second building by setting up a standby data center at that location, which would serve as their disaster recovery site. Management has indicated they've only budgeted for an additional 20 NSX Advanced licenses for ESXi hosts at the second location, and that they've installed a redundant routed or layer 3 connection between the two sites using different WAN providers. All right, so DR, very interesting topic. So our requirement is, I think, quite a common one, which is the customer expects to be able to restore workloads at the DR site in the event of a disaster. And all of the things that encompass that statement, such as the same functionality and the same performance and the same security and things like that. So
yeah, I think that's a really good point here. Is that I'd probably add one other requirement here, which is the customer's expectation is that the security will fail over as well. So the DFW groups for distributed firewall, which was the primary focus of the single site, they would expect that to be here as well in the secondary site if they did have to bring up workloads there.
Absolutely. So I think customers very often say they want something like for like. I hear quite a lot. Yeah. And the important thing as architects is we really should define what like for like means and make sure it's measurable as well. So constraints. So this decision is much more in depth than the first, and I find it quite interesting. So if we were going to protect and provide DR, there's a whole bunch of options that we can go through. So can you run us through what those options are?
Sure. The two primary things to consider with respect to multiple sites when you get into NSX is, first of all, there's two options for multiple sites. You have multi-site and you have federation. We've already kind of had a glimpse of what federation is. Because this is just DR with two locations, we're going to kind of just focus on that. And with respect to multi-site, you can either do it supports a stretched cluster for the management domain or for the management cluster, or a non-stretched cluster, one in each side. So yeah, the non-stretched option as well as the stretched option. So when you start looking at, if you can go back to the previous slide there. And so when we have,
my apologies, I've messed up the slides here. Technical difficulties.
No worries.
All right, it's that one.
There we go.
My apologies.
So when we start looking at having a stretch management cluster, then we're going to start seeing what are the dependencies to be able to deploy the stretch management cluster. And if we're looking at using vSAN for the storage of that stretched vSphere cluster, latency has to be underneath 5 milliseconds, and we have to have 10 gig bandwidth between the two sites. So unfortunately, because we are further than 5 milliseconds apart, we're not going to be able to do a stretched vSAN cluster between the two sites. So we call this, from an NSX perspective, and there's an automatic recovery, which is where if we have a stretched cluster, we can configure it such that we have, where if there's a failure at a site, after a little bit of time, the recovery of it is completely automatic. Or if we cannot have the stretch cluster, then we have what's called the manual scripted recovery, which is the case if we are not within the appropriate latencies. So in order for us to have, by the way, let me expand on the stretch cluster just to be thorough on that. If indeed somebody does go down the path of doing the stretch cluster, the recovery of the NSX manager and its nodes, it's relying on vSphere HA to protect those nodes. So that's the benefit of the stretch cluster, but there's a lot more involved with that and many more constraints. So regarding the other pieces of the NSX environment, we also have the edge nodes. And within a given edge node cluster, and I realize we haven't really talked about the different pieces of NSX. So, Josh, do you want to pause here and we can go over the different pieces? Do you think that'd be helpful?
Yeah, I think so. Let's dive into each piece, and I'll put a graphic up on the screen as well. So as you're talking through those, we can reference that. But yeah, please fire away.
Perfect. Yeah, so let's backtrack and talk about the different components. So the first thing is the NSX Manager cluster. The NSX Manager cluster is the brains of the NSX solution. It's a cluster of 3 nodes. It's a quorum of 3 nodes, I should say. And those 3 comprise the management and the control plane of the environment. And so there also are edge nodes. Edge nodes are the on-off ramp, you can think of it as. Whereas when you have traffic or when you have data in NSX and it's flowing and needs to go out to the physical world, the overlay traffic within NSX goes through an edge node and it goes from there to the physical world and out, through essentially VLANs and things like that that we're all very much familiar with. On top of that, you also have something called transport nodes. And transport nodes are your various ESXi hosts, or really anything that can support an overlay network. So your edge nodes are also transport nodes because they can support overlay networking through Geneve protocol and so on. So those are the primary components of NSX. And so now that we've talked about those, we've already discussed the nodes in constraint number 1 for the NSX manager nodes. And constraint number 2 has to do with the edge nodes. So for a given edge node cluster, and again, a cluster is made up of one or more edge nodes, all of the nodes of a given cluster must be within 10 milliseconds of each other. So with the automatic recovery, you can split the edge nodes between two sites for a given cluster if those two sites are close enough. In our case, we're not close enough, so we're not going to be able to split those because we are over the 10 milliseconds. Same goes for the NSX manager nodes. The nodes of an NSX manager cluster must be within 10 milliseconds of each other in order for the replication of the NSX manager cluster to work properly and to be stable and really to be in a supported configuration.
I think that's the key point is we want to make sure any decision we make is supported because we certainly don't want to have day 2 operations struggling and troubleshooting problems and then for VMware support to come back and say, oh, this is unsupported, because that would leave the customer in a very bad spot. So, and potentially an untested configuration as well, which is even worse. So absolutely, we want to make sure everything is strictly supported.
Exactly. Yeah, good point. So the next item that is a requirement, this comes from the NSX side as well, is the round trip time between the pieces of the environment. So our round trip time in our environment is 24 milliseconds between the two sites. So because it's greater than 10 milliseconds and less than 150, and just so you know where that 150 came from, that 150 is the maximum round trip time between a transport node and the management cluster. So in 24, we are less than that. So because we are over 10 and we're still within the limit of the 150, mainly because we're over 10 milliseconds, that puts us in the manual scripted recovery. And the big difference, we hadn't gotten into the nitty gritty of this, but the big difference between the stretch cluster with the automatic recovery and the non-stretched cluster with the manual recovery is that in the automatic recovery, the management VLAN or the management network is also stretched between the two sites. Whereas with the manual recovery, each site has its own management network. And so that's just something to be aware of. That's further differences between the two. Also, we see here that the customers implemented routed connections between the two sites. So even if they wanted to attempt to stretch a underlay VLAN between the two, they don't have the ability to without using other technologies, which of course they don't have funds to go and get or to purchase. So they don't have any way of stretching a VLAN. So they will have separate, management networks at both of the two sites. They do have advanced licensing. They've indicated that must be used. And so that also limits what our options or what our choices can be for the different deployment topologies.
And specifically, it eliminates the choice of Federation.
Correct. Federation requires Enterprise Plus licensing for all of the NSX nodes. So that's because of that, we don't have NSX Federation as an option in this particular case.
And this number 7 is hilarious. I remember preparing these slides, but this is a real world problem that is a constraint for a lot of customers. And this one is really simple. It's due to hard coded applications and legacy technical debt. the workload IP addresses cannot be changed. I've heard this so many times, and I've had this issue in countless environments, and it's something we need to consider when we're designing something like NSX. So that's why we put it in this example, because it happens all the time.
Yep, I've been there as well. I've seen that, and I've run across that, and I couldn't agree more.
And the last one actually is similar. So in this case, the customer has yet to decide on the solution to recover their workloads. We're actually only talking about the NSX layer in this decision. So this is something we don't know what they're going to choose. They might use VMware Site Recovery Manager. They might use something else, but we don't know at this point. So we're making some assumptions here.
And we'll talk a little bit more about that as it relates to the NSX Manager nodes as we go through this discussion as well.
All right, moving on. So, slide technical problems again. So, risks. Got some latency on these slides that we need to troubleshoot. Lewis, what do you recommend?
NSX SD-WAN?
Yeah, absolutely. All right, so let's talk some risks. So both WAN providers, of course, could have an outage at the same time. So I think the impact of that risk is quite catastrophic, and it's pretty obvious what that would cause, which is the two sites are completely disconnected. So that would be a bit of a struggle.
And I would like just to provide a bit more clarity on this. When we say WAN providers, we're talking about the internal DCI, essentially, the data center interconnects between the data centers. We're not talking about the internet, the DIAs, the direct internet access connections. This is specifically the site-to-site private connections that are provided by the WAN providers.
Absolutely. So as additional workloads get provisioned in the production data center, there may not be sufficient capacity in the DR site to support all workloads. So this really comes back to our constraint around budget and the inability to purchase new hardware. But certainly something that's quite common again in the real world is you have a DR site, production keeps getting scaled and scaled to support more and more workloads, and they get the latest and greatest technology, the biggest and baddest SAN or the best HCI environment, and then DR's held together with some duct tape and some strings. So this is definitely something to consider when you're putting in a DR solution, especially if it's on-prem where there's not the flexibility of a hyperscaler. In the event of a DR failover, you may have a lot less resource, so you really need to understand what you're going to fail over.
Yeah, so and a good thing here is to talk with the customer, find out what their oversubscription, what they can, what they're willing to accept in terms of oversubscription, and make sure that they're within those limits. I've had those discussions many of times.
Absolutely. Oops, sorry. Gone forward again. Okay, so talk to us about the loss of an NSX manager node. What would that do for this customer?
Okay. So in a healthy environment, as I mentioned earlier, the NSX manager cluster is comprised of 3 manager nodes. And so if all 3 are running, there's a quorum, and that's the key point here to keep in mind is the quorum. So all 3 nodes are healthy, they see each other, life is good, full functionality. If for some reason, by the way, that's also why you want to put an anti-affinity rule on those VMs to spread them out across different physical nodes or ESXi hosts, so that if there is a loss of a host in the environment, it minimizes the impact that we'll be covering here. So if you lose a single node of the management cluster, things continue to operate. I still have a quorum of 2 out of the 3. When I lose my second NSX manager out of the 3, then at that point, the whole environment goes into read-only mode. It can no longer update the critical tables that are used to keep track of where workloads are. It essentially freezes everything. So if I have a VM that is running on host number ESXi host number 2, the communication between all of the VMs and workloads that were in place when the second edge or the second manager node failed will continue to be programmed in the forwarding plane. However, anything new cannot be added. So if I spin up a new VM, it's not going to be able to connect to the environment, to the overlays, and the other workloads won't know about it, and so on. VM or vMotions will fail as well because the VM is not going to be able to vMotion to a different host and attach itself on the network of that other host. So you essentially are you're still functioning, traffic is still forwarding, but you're in a frozen environment. Loss of the third manager node, at that point you lose your entire control plane. Whatever is programmed in the forwarding plane of the ESXi host will continue to forward accordingly, but now you've got much bigger problems. You've got to really have that manager cluster recovered or rebuilt or something, and you don't want to ever get to that point, which is why you want to do the things, as I mentioned, like the anti-affinity rules and a lot of other things you can do to minimize the impact or a single point of failure taking things down.
Yeah, and these are certainly topics that we'll cover in future episodes as well, because it's not just the deployment topology that matters, it's how it's implemented.
Yeah. And I can expand also on the fourth risk is that if you do need to, so with restoration, I guess there's two different ways you can take that. If I lose a single NSX Manager cluster, if I lose a single node of the NSX Manager cluster, restoring full functionality would be to get it to 3. I could either get that VM powered back up if that's all it was, or I could maybe remove that node of the cluster and deploy a new node, getting it back to 3. So that's one way of restoring services there, restoring to a completely healthy manager. The other way to take that restoration is if I lost the entire cluster and I needed to restore that cluster. The only supported restoration method for NSX Manager is from NSX backups. You cannot use a product that will do a snapshot. In fact, snapshots are disabled on the NSX Manager nodes. And so you can't even perform a snapshot of a manager node unless you go in and start tweaking things, which then you get an unsupported configuration. But bottom line, it's not a supported restoration method. So if you do have to restore, you have to restore from the backups that NSX Manager made, and you have to make sure to restore to the same version. And there's a whole process to that, and it all depends on what deployment method we are in to determine what is the restoration method of the managers.
Yeah, and of course, the reason we call this out is it impacts your recovery time objective
Yes.
and potentially recovery point objective, certainly for the NSX Manager piece at least.
Definitely.
All right. Moving on to assumptions. So we have quite a lot of assumptions here, which really should be translated into risks, as every good architect knows. So our assumption is the round trip time between the sites will always be sub 150. So obviously this is essential for support. So that's quite.
I'm sorry. Go ahead. I didn't mean to cut you off.
I was just going to say it's very important, obviously, to maintain a supported configuration. So it might sound obvious, but very important that we validate that.
And where that comes from, again, the 150, I mentioned it earlier, is from a transport node to a management node, they have maximum of 150 milliseconds. So that's where that assumption time comes from.
All right. So from a WAN provider perspective, we're assuming that the WAN characteristics in terms of bandwidth and latency and so forth are similar. Obviously, we don't want to have a situation where we go from one to the other and we have a significant change in functionality or performance. So that's an assumption we're making in this decision, which we would, of course, validate if this was a real scenario.
Yep.
The other assumption is that we're only going to have one data center with powered on virtual machines. So the DR side is sitting there as basically a warm standby in this case.
Correct.
And the fourth one, the recovery time objective, the all-important RTO, of course, is long enough to support the recovery of the NSX management cluster and workload VMs. So this is something that hasn't been defined because they haven't chosen their solution for DR. So this is something we're assuming at this point. But of course, as your point earlier, you mentioned that NSX Manager needs to be available to power on new workloads. So when we're designing a DR solution and we're taking into account our RTO, NSX Manager needs to be at the start of that. And then once it's recovered, that's when you can start recovering the rest of the workloads.
Yeah, that's critical.
And a few of these are, again, quite obvious, but we, of course, put these in just in case they're not obvious to some environments, which is the DR site has to have sufficient power and cooling, as well as redundancy to meet the customer's N+1 corporate requirements. So might sound obvious, but something we need to, of course, validate if this was a real scenario.
Yeah.
DNS is always a problem, so I'm glad we're covering this one, Lewis. I'll let you take this one.
Yeah, so in a multi-site configuration, we're talking about remember, we're in a manual/scripted recovery. So, and we do not have, and each site, if you recall, has its own management subnet. So because each of the two sites have their own management subnet, the IP networks for those subnets will be different. So if currently all of the if all of the NSX managers are running at the active site and there's a DR event and we need to bring those up at the recovery site, it is going to be on a different IP network. And so when you deploy NSX, the default method by which transport nodes find the NSX managers is it's hard-coded by IP address. And so in this scenario, you can imagine if we're having to move the managers from the active site to the recovery site, their IPs are going to change. The transport nodes will never find the management nodes, and we are in a world of hurt, and we've got bigger issues to deal with. So what they have done is when a multi-site configuration, and you can enable this on other configurations as well, but multi-site is where it's really applicable to the most, is the scenario of the manual recovery, where I do have to I have to essentially reconstitute or rebuild or bring back up. I don't want to use the term rebuild because that assumes we lost all of our data, but we need to do a restore of our management clusters at the secondary site. But because it has a different management address, they're going to have new IPs for the management clusters. So because of that, we want NSX, specifically the transport nodes, to locate the NSX managers not by IP, but by the FQDN. And so there is an API call you can make in a multi-site, really in any configuration, but in this particular scenario, that tells the transport nodes in the NSX environment to no longer use static IP addresses, but locate the managers through DNS names. And it's important for the reasons I've mentioned that we leverage DNS for that. And because the recovery can, or as part of the recovery, we want all the nodes to transition as quickly as possible to the restored NSX management cluster. For that reason, we want to put a very low TTL time, and 5 minutes is usually, as low as you need to go. That way, the DNS caches will expire on the various transport nodes. They'll start querying as you update DNS, as you're getting ready to do your restore. All the transport nodes will already have the new addresses from DNS, and the minute that the NSX manager is back online, the transport nodes will then start communicating with the restored manager, and you're good to go. So that's why in a multi-site environment, it's so critical to do that API call to flip it, if you will, from static IPs to FQDN is for that DR recovery scenario.
Absolutely. So it just goes to show there's a lot of detail when talking about DR. It's not just, our RTO is an hour, right? It's, okay, what's made up of that hour? And in this case, we've got 5 minutes where DNS could be a factor. So for a maximum of 5 minutes. So
hold on, Josh, I'm confused. Isn't there just a big red button? You just hit the big red button and everything swings over to the DR site? Isn't that how it is?
That's how we make it appear. But yes, of course, there's a lot of detail going into DR. 7 and 8, obviously, we're going to have internet connection at both sites, which is separate to the interconnectivity between the data centers, of course, and that both the WAN circuits support the jumbo frames MTU 9,000 bytes.
And the reason why we need the 9000, we really haven't gotten into that, but that's because we're going to be leveraging overlay networking with that utilizes Geneve. So the packets that need to be supported, or that the underlay needs to support larger MTUs to be able to carry that Geneve traffic.
All right. So our options, which we've somewhat alluded to already, and similar options to our first decision. So we've got NSX multi-site in a non-stretched configuration, which is exactly what we did in our first decision, in fact. Oh, sorry. In our first decision, we had nothing stretched. We didn't have multi-site, and we just had a single site deployment.
Right.
In the second option, you can have multi-site with that stretched environment we talked to, with the management cluster, and we can also have federation. So these are our options, but obviously our constraints have really dictated where we're going with this one.
Exactly.
And not surprisingly, we do need to support 2 data centers, so our single site wouldn't work. And federation we can't do due to licensing constraints. So that leaves us with multi-site and a stretched or non-stretched environment. So in this case, what was the driver behind going down the non-stretched route?
It was the round trip time between the 2 data centers. We were out of compliance in terms of being able to do a vSAN stretch cluster or anything like that, which led us down to the path of the non-stretch. It was also, we didn't have a stretched management VLAN between the 2 either.
So there's a great example of some decisions are almost made for you with your constraints. So just understanding the different topologies and their requirements is critical to making sure you get your decision right here. So our justifications. So we already alluded to this one as well. The customer has advanced licensing. So with advanced, we can't do federation. So our constraint number 6 was we must use the advanced licensing. So we are going to do that. The customer needs to support 2 locations. Multi-site does that. So we are meeting that requirement as well. And stretch cluster isn't supported, as you mentioned, Lewis, that we're greater than 5 milliseconds. If we were to deploy a stretch cluster with, say, vSAN or another technology, and that latency was beyond that, performance would be terrible. Reliability would go down. It wouldn't be supported. It would just not be a good way to deploy this, especially for something critical like DR.
And do keep in mind, I know we've focused on the stretched vSphere cluster here, and specifically vSAN with the 5 milliseconds. But you also have, if you do want to, or if you did want to stretch the management cluster and try to do the automatic recovery, you're now within the 10 millisecond. You're now within the 10 millisecond constraints of NSX. So you need to take into consideration not only the constraints on the vSphere cluster side, but also the constraints from the NSX side, and both need to be compliant.
Absolutely. Yeah, it's not just one product's requirements. It all has to be interoperable.
Exactly.
And effectively, we design to the lowest common denominator in scenarios like this. So in this case, the constraint was NSX, and we couldn't do a stretch cluster either. So we were kind of limited in what we could do based on the environment. So number 4, do you want to talk to the edge clusters?
Sure. This gets back to what I mentioned earlier about the nodes of a NSX edge cluster need to be within 10 milliseconds of each other. So and that's for an automatic recovery. Even if we wanted to stretch or separate out the nodes of an edge cluster to 2 different sites, in this circumstance we couldn't because we're 24 milliseconds apart. And again, those edge nodes must be within 10 milliseconds of each other. So in this particular scenario, that would make it so that, or the result of that would be that for any given edge cluster, all of its members would be at the same site.
And we've probably said this one to death. The round trip time between the management cluster and transport nodes must be less than 150 milliseconds.
Which we satisfy.
We do indeed. All right, so implications. Again, we've got a lot here. It's quite a complicated scenario. What have we got here?
So the first one is something we've talked about already. This was the failure scenario of restoring the manager in a multi-site environment at the secondary site. We talked about the locating the manager via FQDN instead of IP. So that's really what item number 1 is about. The second item relating to the resiliency and high availability of DNS is that you want to make sure your DNS is not solely, or your DNS servers are not solely at your primary site. Should you have a DR event, your secondary site's going to need to resolve those names as well. So you want to make sure that you have DNS servers at both locations that you can actually go in and change the TTL on if needed, or make edits to the A records and reverse records if needed during the recovery. And that's a really good point to bring up as well, in that you need to update not only the forward but also the reverse records. So you want to make sure to have both of those deployed in your environment. Did you want to talk about number 3, or would you like me to continue on?
Number 3, I don't think we've covered this concept at all. So maybe you can give us the concept of local egress, and then we can talk to the implication.
Certainly. So local egress is so let's just say we have a whole bunch of VMs on a single stretched network segment. We'll call it an overlay segment. And so I have some workloads in site A, some workloads in site B, which I know is not our scenario, but just using this example to explain this. Local egress means the VMs in site A would want to send internet or egressing traffic out through their connection in site A. Whereas the VMs running on site B, when they go to talk to the internet, they're going to send their traffic out site B. So that's their respective to the VM and the site they are on, which site they go out. They'll always, if local egress is in play, then they will go out to their respective local egress locations, or egress points. So in this scenario, because multi-site is really, you can think of it as a single site that is extended through a DCI to a secondary location. Well, in that circumstance, for any given network, for any given overlay network, it's going to go out the same way, and it's going to go out wherever the egress is for that. We didn't get into T1s, T0s, and things. It's kind of not what this talk was about, but the traffic will flow up that path and go out. So even if I have workloads at site A and site B, in this scenario of the multi-site, they will all egress through the same path. So it may be site A where everything egresses out of. So there isn't local egress capability in the situation of a multi-site for any given network. They will always travel the same path. Now that's not to say I could not design the environment so that I have some networks that go out site A and some networks that go out site B. That's not local egress. It's really designed in that way. Local egress is where if I have, like I said, workloads on the same shared network at 2 locations. So in multi-site, there isn't the local egress capability. So all the north-south traffic, as we call it, that is egressing will go out through whatever site is handling the egress for that environment.
Absolutely. And the next one you've talked to as well, that the automatic recovery feature won't be supported due to the latency being greater than 10 milliseconds. And that leads us to number 5, of course, which is a manual restore from the NSX backup, which is SFTP at the DR site will be required. So not automated, something we need to plan for, understand the steps, and have a procedure in place for this to be successful.
Yeah, and it is quite involved with the multi-site, so you do need to take that into account. Like you're saying, have an SOP, have something to try to walk through it, step through it, validate the restore procedure, and then that way you're ready if that time ever comes.
Absolutely, because a customer's not going to meet their RTO if they don't know the steps involved with their recovery when it comes time to do it. And certainly in a DR scenario, in a stressful time, we as humans forget things, we make mistakes. So it's important that as architects, we always deliver those procedures, make sure they're handed over and well understood by the customer, who has already undergone training, of course, at this point and understands the concepts we're talking to in those procedures. So, yeah, very important to understand that piece.
And a key item here too is NSX does require a secure FTP server, so it cannot be just an FTP server. It has to be an SFTP server, which is why we've called it out there.
Mm.
And continuing on to number 6, the reason why that's there is so you have your active site and you have your recovery site. And the way that the recovery works in a manual recovery is you're leveraging continuous backups. So you will place an SFTP server at the opposite data center. So for the nodes and for the manager that is in the active, you'll place an SFTP server in the standby data center, and you will have continuous backups. Whenever the DR event occurs, you go and you restore the most recent backup that finished, and that is what you use to then bootstrap and bring back up the NSX managers and thus the environment. But the key there is continuous backups. So minute one backup finishes, NSX will immediately start on another backup, and the target for the backups must be an SFTP server.
Yeah, and this is extremely critical, as point 7 highlights here, that the recovery of your workloads can only begin after the successful recovery of the NSX management cluster at the secondary site. So making sure that's well understood and people don't expect that VMs can come up prior to that is very important.
And by recovery there, just realize I take that to mean that in my mind, a workload is not fully recovered until it is on the network, being able to forward traffic and so on. So it isn't just powering up a VM that we're referring to there. It's the whole process of bringing a VM back online to full recovery and participating with traffic on the network.
Yeah, full production functionality.
Exactly.
Yeah, absolutely. Yeah, obviously we can power on a VM with a NIC disconnected, but it's not much good at that point. So
exactly.
We certainly don't want to be in that position. So our last couple of implications.
Number 8. This is something that is often overlooked, and it really needs to be understood. So in a multi-site configuration, we haven't talked about a TEP yet. A TEP stands for tunnel endpoint. We've spoken about the Geneva tunnel. So if I have 2 different ESXi hosts and I have VMs on each and they need to communicate via an overlay tunnel, the ends of the Geneva tunnel will be this tunnel endpoint. It will be the source and the destination of that Geneva communication. And so in a multi-site configuration, all of the communication from the various transport nodes are always TEP to TEP. The reason why this is important to understand is if I have 100 ESXi hosts in site A and 100 ESXi hosts in site B, or the recovery site, any host in site A, when they go to communicate, can communicate and send a Geneva traffic to any host in site B. Well, that gives you the amount of tunnels that can be created is quite large with that. I think it's n times n minus 1 factorial. Gosh, I forget the formula now. But I believe that's what it is.
Yeah, it's a big number. That's the key point.
So with each of those tunnels, you're now going to have state that the underlay physical world needs to keep, or I should say, there's going to be a lot of state that is generated in the underlay. So if you have physical edge firewalls at your location, that traffic is going to go through those, which means there's going to be state that those physical edge firewalls are going to be needing to maintain. So that state, given how many flows could be occurring, can be quite substantial. So you need to take that into consideration. And that is just the way by which multi-site works. And you just need to be aware of that so you can make sure that the sizing of your firewalls can support that.
And I think the last one you've touched on already, but NSX manager clusters must be configured to use the FQDN to force the transport nodes to resolve via FQDN. And that is an API call, I understand.
Correct. There's nothing in the GUI to enable that. It's a single API call done once. Once it's done, then the NSX manager communicates to the transport nodes, and the transport nodes will then switch over to using FQDN. The important thing to point out here is this is not something that you just do, well, I'm just going to go ahead and throw this API call in there and get it converted. You need to make sure that your DNS has the proper, both forward and reverse, the proper names or the proper A records and PTR records. And also, and this is another item that's often overlooked, before you do this, you need to go in, you need SSH into your control or into your one of your NSX managers and verify that the FQDN that it shows is what you think it is, so that, because that is what is going to be handed out to the various nodes in the environment. So you're going to want to check your FQDNs on your managers, check your DNS forward and reverse. At that point, and only at that point, if everything looks good, then you can do this single API call to switch over from IP to FQDN.
Absolutely. So this is a great example of not just putting something in your design to talk about the end state, it's also giving some documentation on how to get there and the process involved. Because obviously if we skipped any of those steps, the result's not going to be what we wanted.
Yep.
All right, so there's a lot of miscellaneous items to consider here, and NSX is one of those topics where we thought there'd be value in talking to some of these. So do you want to run us through some of these, and feel free to go as deep as you want, because I think they're all very interesting from our prep calls.
So NSX Manager nodes, all the nodes, as we've mentioned previously, all the nodes of an NSX Manager cluster must be within 10 milliseconds of each other. If they're over 10 milliseconds, then at that point you're in an unsupported configuration. So that is important to keep in mind. Now, I'll just leave that at that. So in our situation, the stretch vSphere cluster isn't supported due to the latency between the data centers of 24 milliseconds, which we've talked through multiple times. So that's something to keep in mind. Again, the stretch vSAN it has to be less than 5 milliseconds, which we don't have. So that was a limiting factor here. The latency between the members of an edge node cluster or of an edge cluster, all the nodes need to be within 10 milliseconds, that we've talked through as well. This number 5 is something we haven't talked about yet, which is an important item to kind of talk or touch upon. When you configure an NSX manager cluster, assuming all the nodes are on the same IP network, you can go in through NSX and have the NSX manager cluster actually provide a VIP and for that cluster. And the VIP stands for virtual IP address. And then everybody in the environment who needs to talk to the NSX manager, the users, maybe have some automation, they all just point at that VIP. And they'll be that VIP will then land them on a manager and so on, and life is good. The item to keep in mind here is that all of those 3 nodes of the NSX manager must be on the same IP network. So if all of the nodes are not deployed on the same IP network, then we cannot use the built-in VIP of the NSX manager cluster. And keep in mind, the only way that you could deploy the NSX managers across different IP networks is if they're within 10 milliseconds of each other, because you have to make sure that every node within the NSX manager cluster can talk to every other NSX manager node, and with a latency no more than, or has to be under 10 milliseconds. That is not a normal configuration. With something like this, though, if we wanted to try to minimize the recovery time, and if which we are not in that situation, but if we had 2 sites that were within the 10 milliseconds, you could potentially take one of those nodes, put them in the other data center, and still have the 3 nodes of the cluster. You'd have 2 in one site and then 1 in the other. The gotcha there is you can no longer use the VIP that NSX provides. So if you do that, you're going to have to then use a external hardware load balancing to provide that VIP. That's not something I normally see being done, but just wanted to point that out so you're aware of it, because it is part of the decision process as to what you're going to need to do. And item 7, we've talked about numerous times. Transport nodes need to be within 150 milliseconds of the management node.
Fantastic. And again, related decisions, we've got a lot of topics coming. The first decision we already talked to, and obviously the next one is 3 data centers or more. So excited to jump into this one. All right. So our third decision, not surprisingly, is we're looking at the NSX deployment topology across 3 data centers.
Oh, come on, Josh. Who needs more than 2 data centers? Come on, it never happens.
I'm working with a customer with 4 at the moment, so. So 3 data centers. The customer has expanded again. Acme Corporation, a very successful corporation, clearly, because they're expanding quite a lot. Their budget constraints seem to be going away very quickly in this scenario. And they've acquired a 3rd building. The customer would like to have the ability to run any given workload in any data center, which is, not an insignificant task. And they would like to maintain the strict security controls around their permitted VM to VM communication. They'd like to minimize their WAN traffic. And rather than backhauling egress traffic to the first site, management would like VMs to egress out the local sites. So we did talk about local egress earlier. Given all the sites are considered critical to the business, the customer has decided to provision additional WAN circuits as to create a redundant triangle between the 3 sites. So no budget constraints here for sure. Which NSX deployment topology should be used? This is a good one. So our requirements. So all sites need to have internet connectivity, obviously, for that local egress piece. We want to minimize that WAN traffic, by using local internet traffic. We want to have the ability to run any workload in any data center. So moving things around. I remember about 15 years ago, I did a stretched environment for a customer where they literally moved workloads between 3 data centers across a campus. They did that for many reasons, and it was quite a fun project. So this does happen in the real world for those listening. They want to maintain the strict security controls, of course. You can't go from one data center to another and completely lose your compliance. And the last one, I think, is key, not only for the implementation, but for obviously ongoing operations, is we want to simplify the management and security across those sites. So we don't want to do things manually at each site. That'd be too prone to human error and things like that.
I would like to expand on a couple items that are on this slide here. The first one is to expand on what you mentioned about multiple data centers. I had one client where what they did was they had multiple locations as well, and they had Federation deployment. And when every time that their contracts came up at their respective colo, they looked around, okay, what's the best deal I can get? So they leveraged NSX to be able to migrate workloads from one data center to another, simply to reduce the operational costs by being able to get a better rate at data centers. Mm-hmm. So that is another use case to having the ability to stretch across multiple sites, even though we kind of joke about it a little bit. They were looking, the requirement for them was to be able to support 4 sites. 3 active, in that other 4th was for the newly discovered data center that they were migrating to. Mm. So things like that are what you can start thinking about. The other thing too, when we talk about local egress, I just want to add a little clarity to this. Realize that when we talk about local egress, it is relative to the NSX environment, because the minute it goes across that edge node, it's just going to hand it off northbound. And so at that point, it'll depend on the underlay routing at that location to carry that traffic out to the internet or wherever the routing tables lead it. So we are focused here specifically on where NSX egresses traffic from NSX. So I just wanted to clarify that, because often, yes, sites will need to have local internet, because often they'll want to have that traffic egress locally, but the actual on-ramp, off-ramp of NSX is still inside from the edge. And then at that point, it transits out towards the physical internet edge by local routing tables. So I hope that I just wanted to provide a little clarity on that.
And in fact, your scenario you mentioned, I think that's a really good concept to think about for customers. Slightly off topic, but if you have a way where you can exit a data center or exit a hyperscaler, that's a great business outcome to have. You can use that to your commercial advantage. You can use it to your technical advantage. So certainly, getting in and out of locations is important. And in the scenario I alluded to earlier, the customer basically, even though it was their own data centers in the 3 sites, they needed to pull down that building. So we actually moved the workloads out of that data center. They were able to, demolish that building, rebuild that building and data center, and then move those workloads back once it was rebuilt. So that there's lots of reasons to do this, and it's not just to make cool technical solutions that Lewis and I can talk to on a podcast. There's actually a lot of value in them.
Yeah, exactly. The other thing I'll point out is on local egress.
Oh, sorry.
Yeah, no worries. I just thought about this. It's something that often gets overlooked, so I just wanted to mention it. Is keep in mind you need to think about egress traffic and ingress. So you need to plan and design for both of those. We're talking specifically about egress here, and this particular client or this scenario doesn't have any internet-facing services, so we're not talking about ingress here, but you need to take that into account either by leveraging, if you do have services at each of the different data centers and you're needing to support ingress, that's where something like a load balancer is needed to bring that traffic there and then inward from there. So just keep aware that egress and ingress need to be thought of separately and handled accordingly.
All right. So our constraints. So this one here, maybe you can talk to these because they're different limits than what we've heard of previously.
Yeah, we haven't talked about RTEPs or remote tunnel endpoints yet. And so I'm letting the cat out of the bag a little bit here, but in a NSX Federation deployment, if you recall when we talked about NSX multi-site, I mentioned about the amount of state that gets created from the TEP to TEP communication and how it can be quite a bit because of the if I have 100 and 100 ESXi nodes, all of the tunnels that could be established in all the state. The way that they resolve that in Federation is now you no longer have ESXi hosts in site A to talk to an ESXi host in another site directly. They will all send their traffic up to the edge nodes, and then the edge nodes have something called a remote TEP or an RTEP. And so when traffic goes from one site to another, the traffic will go up to the edge, and then an RTEP to RTEP communication occurs, and then the traffic comes back in. So we reduce greatly the amount of state in the network. Everything that's site-to-site communication travels through the edge nodes, which is now something else you need to take into consideration when it comes time to size those and think about bandwidth consideration, things like that. So in the Federation, the RTEPs of the solution must be within 500 milliseconds of each other. And so that's one of the constraints from NSX.
Yeah, absolutely. I think that state is something that's very important to understand, and certainly something when you're learning about NSX, it makes sense that your TEP and your RTEP are different and they serve different functions.
Definitely. Oh, the other thing too is the RTEP. So the TEP does not support fragmentation. So that's why you need the jumbo support on your DCIs or your WAN links between really the nodes. And if you have across 2 different sites, the DCI needs to support that jumbo frame. Whereas here with an RTEP, the RTEP is the only TEP that supports fragmentation. Not suggesting it. You definitely do want to try to send the RTEPs over a jumbo type circuit. But if you do not have that ability, and that is a constraint where you can only go to 1500 MTU, it'll still function as long as the traffic is sent via the RTEP. So that would put you in a Federation deployment with multiple sites.
And so our round trip between the 3 sites has increased, actually. So in our previous example, I think it was 24, and now we're up at 68 milliseconds.
Correct. Yes. Site 3 in this example is on the other coast of the U.S., so our round trip times increase. We're 3 talking to either sites 1 or 2 was 68.
Mm. And this third one was quite interesting when we were talking through this scenario. You went into a lot of detail about, making sure we're always checking documentation for features which are supported, because, a layman's view might be that, Federation, it's the biggest and baddest deployment type. It must do everything. Well, that may or may not be the case. So very important, depending on the version and when you're doing your deployment and design, that we check which features are supported and are not supported, and we don't assume that we've got everything going from a single site to multi to Federation.
Exactly. And the other thing too, and this may get a little confusing, but let me try to clarify something here. A few things. First of all, around constraint number 3, when we talk about Federation, we're talking about the features that are supported on the global the global NSX Manager cluster. Remember earlier I mentioned we have a global NSX Manager cluster, but then each site has its own local NSX Manager cluster. So the features that you may need may not be supported across all of the sites at the global level, but you may still be able to leverage some of those features at a local level. However, the global objects and the local objects are different objects. And what I'm saying here now gets very confusing very fast. And so you need to make sure that the service that you are trying to use, let's say you're using, a great example is service insertion. If you are trying to do service insertion in Federation, you cannot do it at the global level or any global object. It is only supported at the local manager against local objects. So you just be aware of that, where it can be used, and because you're limited on the objects that can apply to, you're limited on what those objects support. For example, if I have a stretched segment across all my different sites, let's say I have 3 sites like this example, because I'm stretching that segment, that automatically makes it a global object because that is created in the global manager. However, I may still have segments at each location that I have created on the local manager, which are local objects. On those segments, I can implement service insertion, but those networks are site by site or site specific or site centric, and so I cannot take any traffic that goes across the entire enterprise and also use that service insertion. They're 2 separate worlds managed by 2 separate NSX manager clusters, and you need to be aware of that. The other thing I will point out, I can't tell you how many times I've looked at third-party data sheets where they say, yes, we support NSX version 3.2 or 4.1 or something. But then you dig into it and you're like, oh, well, yes, they say they support this version of NSX, but what I'm trying to do is in a global manager, they don't clarify whether it's supported under global or local. So if you are in a Federation sort of environment, you need to verify that besides it just being supported by that version, is it supported in this scenario or in this method or scenario that you're planning on using it. There is a really good table in I believe it's the install guide under the Federation or multi-site section, where it gives a table of the various options that are supported by Federation. The important thing to realize from that table, if it is not on the table, if it's not explicitly stated on the table, you should assume that it is not supported, and then definitely run that by VMware or an architect or somebody that's familiar with it that can help you with it to confirm one way or another. Or even better, spin up a lab and test it there. That's often what I'll do with customers.
Yeah, absolutely. Always validating. We don't like tick box comparisons or tick box support matrices because it's not always representative of real world scenarios. So yeah, that's a great tip. And we'll put a link to that documentation as well so people know exactly what we're talking to. All right,
and
moving on.
Go ahead.
Sorry, you did talk to service insertion and being local only. So I think we've covered that one off.
Agreed.
All right. So our risks. So of course, NSX Federation not necessarily supporting all the services or features could impact future decisions and how we do things, or it could impact operations and other things. So very important to stress that point again, that we understand what is supported, what is not, and in what specific scenario it is supported or is not.
Especially with regard to the impact on future decisions.
Yeah, absolutely. So anytime we make a decision, the reason we spell it out in this way and we talk about implications is because when we make a future change, or we scale in the future, or we add another service or something like that, we might be constrained based on the decision we've made. So this is why people end up re-architecting their environments 3 or 4 times in the normal lifespan of, say, hardware, because they haven't made a decision factoring in all the things they're doing in the future. So if you engage a good architect, a good experienced, VCDX like Luis, for example, he's going to tell you, here's what you can do today, but if you do this, you're going to have to rebuild. So why don't we just prepare for that in phase 1 so that phase 2 can go through very smoothly? So yeah, just a really good tip there for up and coming architects to really think about the future. So our next risk is the round trip time has increased. So applications should be tested to make sure they support and tolerate that latency within an acceptable service level agreement. So anytime you introduce latency or new technology or additional sites or things like that, very important to test before you just move the workloads there. Even though NSX will help us move the workloads there and whatever technology we're using to move the VMs, you still have to test to make sure it works. So I would call that operational verification, and you would definitely want to do that before you moved workloads from a production perspective.
And the last one we touched upon a little bit earlier, I touched upon, was keeping in mind the ingress traffic, and you may need to front end that with a load balancer to handle that, but just don't lose sight of the ingress traffic that's required.
All right, so assumptions. Again, we're going to stress training. Make sure staff who are going to support an environment have training on the specific features and functionality as well that they're going to be using. Because there's no point doing a install, configure, manage class if it doesn't cover Federation and it doesn't cover the key points that you're going to look at. So, Luis actually does exceptionally good enablement specifically for these reasons, because some of it is not covered in official training and doesn't cover all the different scenarios that he's certainly seen in his career. So, yeah, very important. Make sure when you engage an architect that you put in that scope that there is proper training and handover from that architect or from the engineer who's installing and configuring, because, yeah, very important. Now, the next one is when we deploy the global manager cluster, it is a separate 3-node cluster. So we need to have resources to be able to actually run up those 3 additional machines in each site. So we've got an active site and a standby site. So we need resources in those 2 sites for those global manager clusters.
And I should expand on that just a little bit. When you are in Federation, and I've talked about the global manager, it's like a manager of managers, so to speak. You have an active and you have a standby. The active is what you go to, you do all your configuration, your intent, and so on. The active replicates its configuration, or its, what the user has requested be the configuration, to the standby. And that's constantly happening. So a change is made, it gets replicated to the standby. The failure recovery in a Federation environment, if you lose the primary site, which happens to be where the the active global manager is you log into the standby global manager and you essentially hit a tick box or you hit a button. The standby now becomes the active. And that is the recovery for Federation. It is a much simpler recovery than anything like the multi-site we talked about. So, and those are the 6 VMs in total, 3 active global managers at the active site and 3 standby global managers at a different site. And the replication takes place all under the covers for you.
So again, to support those additional workloads, we need hosts at the 3rd site to be able to host those global manager VMs. And obviously, we want to separate them out as well, so they're not all running on the same node and all this kind of stuff. So there's lots of design decisions to follow on this topic. And of course, the third site has to have sufficient power and cooling redundancy, as with our other sites, to meet the customer's N+1 corporate requirement, which I must say is a very smart requirement to have. So please follow this Acme Corporation's guidance with regards to having N+1. Very important.
Just to comment on that, I've worked with some customers that have an N+2 requirement, and it's specific for, their tolerance for a failure is pretty tight. And so there are some scenarios where an N+2 is a good way to go. So just keep that in mind.
Absolutely. There's plenty of scenarios where that's a very important idea.
Mm-hmm.
So risks. Oh, sorry, I've gone back the wrong way. All right, I'm going backwards.
You're going backwards on us.
All right. So our options here. I guess theoretically we could deploy a single location everywhere, but that's probably not going to meet any of our requirements, or it may meet one or two, but certainly that would be very complicated. Multi-site, our constraint here is, of course, it only supports 2 sites. So we actually, again, the requirements have dictated where we're heading with this, and not surprisingly, we've gone down the route of federation.
And keep in mind, if you can go back one slide, is if a client were to choose to do multiple single locations, you would lose the ability to have that single pane of glass for your security, your DFW rules, your firewall rules, and all of that. So that's the reason why that is not a viable option in this situation, because of that requirement.
Yeah, absolutely. I think managing 3 sites individually would be quite a task as well for the administrator. So would be very complicated.
But you also lose some of the firewall capabilities in terms of, if I have a set of, well, there's a lot of pieces to that wouldn't work in the single site. So I'll just leave it at that.
Yeah. All right, so justifications for this decision. Well, NSX Federation being the only one that supports more than 2 is a pretty good one. So that was why we put that one first. And workload VMs on stretched overlay segments must utilize local egress, which was our second requirement. And central management of the strict controls and our VM to VM communication across all locations, including future sites. Obviously, we're planning for the future here as well, was requirement 6. So I think that one is probably key. NSX Federation also supports multiple deployment sizes. So you can have a medium or a large, and medium supports 4 locations, which is obviously greater than 3. So that's fine in this scenario, while a large deployment supports up to 16 locations, but the customer does not expect to scale beyond 3. And if they did, well, medium supports 4 anyway. So if they were at 4 data centers and went to medium, that they're still supported in that scenario.
Yeah, and always look at the documentation to see what version you're looking at deploying. And also there's an online page. I'm drawing a blank now. I forgot what it's called now, but there is a site that shows you all the config max page. Yeah. So the config max page, go there, look up your version of the NSX that you're looking to deploy, and verify that you are still within the maximums.
Yeah, and we'll put a link to that as well, just for anyone who's not familiar with Config Max. But it's actually a tool it used to be a PDF years ago, and you have to download the PDF every time. But now it's very searchable, and it's a fantastic resource. So kudos to VMware for making that much easier for us to use than a PDF.
Definitely.
So medium-sized global manager cluster in NSX 412 supports up to 128 ESX hosts across 4 locations, and that exceeds this customer's expected growth requirements. But again, that's in Config Max, so it's important. If you think you were going to go beyond 128 or you were close to that, you would possibly go with a large deployment to future-proof yourself with that. And of course, number 6, a single site wouldn't satisfy the management and security across 3 sites. So that's really helped us justify that decision. As much as it might sound rough, pretty obvious, I think it's important to write all these things down.
Yeah, definitely.
All right. Moving on to the implications. So you explained beautifully before. You've got the global manager, the manager of managers. So if we have local NSX objects, they're going to need to be converted to global objects for this to function as expected. So that would be a migration task as part of this project.
Yeah, and just keep in mind, you only need to convert, or you only need to have, or how do I say this? Global objects are for things that are across multiple sites. Those live in the global manager. So don't think that it's a requirement to migrate everything. There is an ability to do a migration when you onboard a site, and that's an all or nothing. But as you create objects, it's not like all the objects you create have to be global or local. It depends on what your needs are in terms of how that object is used.
So now we've also got the enterprise-wide firewall rules and groups are now managed at the global level. So this is just an operational consideration. People need to know where they're setting up the new rules.
Yep.
The customer must upgrade all their advanced licensing to Enterprise Plus and purchase the additional licensing for the third site. So licensing, of course, a requirement here, but the customer's got plenty of budget at this stage, so that's not a problem. And also, of course, the RTEP, locally routed VLANs, are required at each site. So that's an additional step required for a federated deployment. And the global manager cluster deployment requirements for those VMs. As at the time we made this content, it was 3 VMs at 6 vCPUs, 24 gig of RAM, and 300 gig of storage. But of course, that may change in different versions, so don't take our word for it. Look up the documentation prior to deployment, which I can tell you I literally do for every design that I do. I double check each of these things because there's been times in my career where I've used a previous design, I've changed the required things, and it turned out to have changed in the latest version. So that can bite you. So very important as you go through your design, even if something is templated, which all of us obviously use templates at some point, just validate each of those things as you go through because it could bite you in the back.
Yep, so true.
All right. So additional resources are needed in the vSphere management cluster at 2 sites because they're going to support the active and standby global manager clusters. So not a huge amount of resource, but still some additional resource required. And of course, I think it goes without saying, but we don't want these the global manager cluster to have any contention, because if it had storage contention, you might get database corruption. If you had CPU contention, it just might perform poorly and not operate as expected. So you wouldn't want to put these global managers in a highly contended, low performance environment. You would want them in a reasonable level of performance. So additional hardware might be required, of course, if we don't have sufficient resources or if we identified performance issues that I just mentioned to host these active and standby clusters. You might need to buy more hardware. Of course, don't skimp on that. This is a key. This is a business critical app. Is the best way to describe the NSX managers and treat it as such.
And by the way, when you do deploy Federation, standby is an option, and you have to take the initiative to go and deploy it and configure it. And don't skimp on that. It's critical that you have both active and standby from a recovery perspective.
Absolutely. I think, anytime you can have some resiliency for a business critical app, especially where it's built in, you should try and do that wherever possible.
Definitely.
So we must be able to stretch the NSX overlay segments across all 3 sites. That's obviously something that needs to be considered, and all the WAN circuits must support jumbo frames to make all this happen.
Actually, I want to clarify that a little bit now. Because we're in a federated deployment scenario here, if we don't have, if the sites are remote enough, and I realize our situation here, we have the communication, we have the appropriate infrastructure, but let's say each of the 3 sites do not have WAN circuits, then because the RTEP does support segmentation or fragmentation,
Yep.
you could send that traffic over 1500, which means it does not have to have 9,000 byte MTU. But in our case, we are doing that for efficiency. So I just wanted the must there is what I just wanted to address.
It really should be should.
Yeah, that should be a should.
Yeah, and that's because of the RTEP. Whereas if this was a normal TEP, it is a must.
Yes, exactly.
And of course, the round trip times do change between NSX versions. So to my earlier point about always checking the documentation for different versions and different capabilities and limits, this is a great example of that. So the RTEP limits for NSX 3.2.3 was less than 150, whereas in NSX 4.1.x, that has increased now to less than 500 milliseconds. So, of course, that's a big difference. So 3.2.3 might not be viable for some customers, depending on their environment, whereas 4.1 may well be viable. So very important, to test those different version numbers.
Yeah, that is critical.
And, of course, we've come to the end. So, again, we've got our related decisions. So we've covered a lot here. From the topology perspective, but of course there's a whole raft of decisions we need to consider. So we'll certainly be back to do those, and we look forward to welcoming Luis back again because I think you're extremely knowledgeable and we've really only scratched the surface of NSX at this point, but clearly you've demonstrated your expertise on the topic. So thank you from everyone and myself for presenting this topic. And look forward to the next one.
You're very welcome. And thank you all for joining us, and look forward to seeing what I can do to assist you in the future.
Fantastic. Thank you.